Okay, so the process of translation. So the first stage we're going to talk about is initiation, so the starting point of this. So a couple of key ideas here. Again, everything starts with AUG, so that's the start codon for the most part. So what's going to happen is the first TNA molecule, charged tRNA molecule, is going to match with the start codon. At the same time, the small ribosomal subunit is going to attach also. And that's going to create what we call the initiation complex. So you see that all right here. So the small ribosomal subunit, the mRNA, and the amino acid, the tRNA molecule. Okay? So, and then what's going to happen in elongation is the large subunit's going to attach, and you see that right here. Okay? And on the large subunit, it's got three sites, which we talked about, the A site, the P site, and the E site. Now, the first codon, the start codon, this one, binds in the P site. The E site's empty for the moment, and what happens is the second charged tRNA molecule, so whatever lines up with this codon here, so this codon here, that tRNA molecule that again is charged because it has an amino acid, is going to bind to that A site. Okay? So notice the E site's still empty. What happens when those two get together is the amino acids are going to bind together. They're going to form a peptide bond or a peptide linkage. Okay? And what's going to happen is this amino acid here is going to detach from that first tRNA molecule. And then the ribosome is going to move one codon, okay, in the 5' to 3' direction. Okay, so while this is going in the 5' to 3', the amino acid, well, leave that, never mind. So as this ribosome moves one codon over, the now empty uncharged tRNA molecule goes to the E site and then it leaves, right? So the E site stands for exit. Um, the second one that was in the A site now moves to the P site, and it's made up of two amino acids now. So what's going to happen then is a third amino acid is going to come into the A site. This amino acid is going to attach to this one, and you now have three amino acids attached to that. Now, what happens to this tRNA? Well, it goes off and gets charged, right? So it picks up another amino acid, some ATP, and the tRNA specific enzyme, and now it becomes charged. It can come back in later on when it's needed. Okay, so that repeats, and you can see here's the original two amino acids. The third one came in here. It's represented right here, and then this has all happened again and again and again. So this happens literally thousands of times. Okay, and then eventually we hit the stop codon. When we hit the stop codon, there's no amino acid associated with that, and what it happens is all these whole complexes, everything just dissociates, everything falls apart, and you have a polypeptide chain here that is now complete, more or less, and ready to do whatever its function is. Okay, and that's the end of uh, translation. Translation, right? And this last step is unsurprisingly called termination. Okay, so just quick reiteration, right? First tRNA molecule, this is methionine, binds to the start area. The small ribosomal subunit also binds to that. That forms the initiation complex. Then the large subunit comes in. Second tRNA molecule comes in. Then a peptide bond is formed. And this amino acid detaches from the first tRNA molecule. Everything moves one codon. That uncharged tRNA molecule, the first one, then is in the E site. It leaves. A new TNA molecule comes into the P site. Its amino acid is going to bind with the other two amino acids, and this is going to repeat hundreds, thousands of times. So eventually you get multiple amino acids joined together, we're forming a polypeptide. Once you hit the stop codon, that causes the small unit to break away, the large ribosomal subunit to break away, the tRNA molecule, and the finished polypeptide to complete away. So the polypeptide goes off. It might have some modifications, but it might just go off and start doing whatever job it's supposed to do. Okay, thank you.